All right, welcome to this video on equations with special solutions. Up to this point, you've only been solving equations that have one solution for the value of the variable, but it's truthful that to say that equations can have any number of solutions. You can have equations that have no solutions, one solution, two solutions, three, four, five, up to infinitely many solutions. Now, in our eighth grade pre-algebra course, we are going to be focusing on equations that have zero solutions, one solutions, and infinitely many solutions in this lesson. Now, later, when we study squares and cubes and square roots, we will do equations with two solutions, and then all the other ones will be left up to Algebra 2. Okay, so I'm going to do examples of equations with one solution, zero solutions, and infinitely many solutions. Starting with equations that have one solution. Okay, until now you've only done these, and this example is one just like what was in the previous lessons. So if we were going to solve the equations, notice when I subtract the 2x on each side, to move my smaller variable to the right and get my variables all to one side, I still have some x's left. I have one x or just x, but those cancel, okay? Whenever that happens, you can keep solving and get what x is. So we can subtract 4 on both sides. We get -9 equals 1x or just x. So we got one solution, and the solution was -9. So number of solutions was 1, and the actual solution was x equals -9. Okay, so now we're going to look at some special solutions, which are the zero solutions and infinitely many solutions. First, we're going to look at equations with infinitely many solutions. All right, like this one. So the first thing you kind of want to do is bring your x's to the same side. And since they're both the same size, it doesn't matter which one you move. So when I go to subtract 5x on each side, look what happens. This is new and special. They end up canceling out on both sides, and I'm left with -2 equals -2. When that happens, when the variables cancel away, and you're left with what we call a true statement, because -2 does equal -2, that means this has infinitely many solutions. Let me just reword this. The number of solutions is infinitely many. And I asked you to write the solution. What is the solution to the equation? You always write x equals, and we will say all real numbers, because that means that any number on the number line, 2, 3, -7.1, whatever, you can put in on the left side of this equation and the right side, and it will make them equal because the two expressions are completely identical. All right, there's a second example like this here. I would recommend that you solve it to see that it turns out to be infinitely many solutions, and then come back and check it. So maybe pause the video now and do that. All right, now I'm going to go ahead and finish solving it. So if we distribute 4x minus 12 equals -12 plus 4x. Okay, so now I'm going to subtract my 4x to get it over to the other side, but oops, everything's going to cancel. I have -12 equals -12, which is a true statement. So x equals all real numbers. I'm going to go back and circle the solution here. X equals all real numbers. You have to write that. You just can't leave it as -2 equals -2. You have to write down that you know what that means, that all numbers are a solution to that equation. All right, so that's equations that have infinitely many solutions. The variables cancel out and the constants are equal. make sure you still remember that if you have any simplifying you can do, you should do that before you do any inverse operations, just as we discussed before. Now we're going to look at equations with no solutions. Okay, so something different is going to happen on these, but you're still going to start by moving your variables to one side, and it's still going to be the case that they're going to be the same and they're going to cancel away. So that is going to cancel out. Okay, now we're left with 3 equals -9, which is not a true statement. It's a false statement. 3 does not equal -9. That's not equal, which means this equation has no solutions. There is no number that you can put in for x that will make the left side and the right side equal. Because if you look at the fact that, like, let's say you put in a number for x, like 1, okay? 6 times 1 is 6. Well, if you add 3, you get 9. But if you take 6 and minus 9, you get -3. So as soon as you take a same number and you do different operations with it, you're going to get different answers. So it will never be equal. So we will write x equals no solutions. So if I ask you how many solutions it has, you'll say 0. If I ask you what is the solution, you have to write x equals no solutions. All right, so I recommend you try this next one. Pause the video, give it a try, and then come back and check it. So when you're solving this one, you need to simplify both sides first. And I see over here we have a 1x plus a 6x, which means we have 7x. All right, so I'm going to go to move my variables to the same side. So I'm going to subtract 7x to move it over to the right so that I have my variables on the right. But oopsie, they cancel out on each side. Okay, and on the right, since there's nothing left, we have to write 0 because you can't have a side of an equation that's blank. So -5 is not equal to 0. So we're going to say that this equation, the solution is x equals no solutions. Okay. So now moving on, I just want to stress how asking for the number of solutions is different than asking for the solution. So here's how you can respond. If you have an equation that has the same amount of x's on both sides, they're going to cancel, and then has 2 and -5, which are not equal, then that means there are going to be 0 solutions to that equation. If you were to solve it out, like -2, -2, that kind of thing, and you would write x equals no solutions if you were asked what is the solution. So this is the answer to the number of solutions, 0. Whether this is the answer to the solution, it's no solutions. Every time you are asked to solve an equation, you should write x equals as your answer. Okay. This next one, when I distribute on the right side, I have 3x minus 6 equals 3x minus 6. These two sides are identical, so the number of solutions is infinitely many. And you can write this, the sideways infinity symbol, if you like. Or we write x equals all real numbers. And then this one, because the x's are different, when you subtract 2x, you will still have an x over here to solve. And I get x equals 7 on that one. So the solution is x equals 7. Number of solutions is that there is one solution, and it's the number x equals 7. So make sure you respond based on the question that is asked. All right, so a couple of application scenarios. Is there a value of x that will allow the triangle below to exist if the perimeter is 4x plus 10? Well, when you're solving an equation with perimeter, we know that we are supposed to add up the sides to get the perimeter. So if I add up the 3 sides of this triangle, I have x plus 7 plus x plus 8 plus x plus 6. That equals to the perimeter, which they'll either give you a number or an algebraic expression. In the case they've given us an algebraic expression, the perimeter is 4x plus 10. So now I'm going to attempt to solve this equation. X, that's 3x. 7 and 8 and 6 is 21. So the way the problem is worded, we can answer right now. Is there a value of x that will allow the triangle to exist? And we can say yes, because the equation, well, let's look what's going to happen. If I subtract my 3x on both sides, I am definitely going to have some x's left. Oh, sorry, equals 21. All right, so because the number of variable constant is 3 on this side and 4 on that one, which is different, just like right up here, 3 and 2 are different. If the variables are different, your equation is definitely going to have one solution. So yeah, we can solve it. If we get x equals 11, we can see that's going to work. Yes, the equation has one solution of x equals 11. So that will work. Okay. Now you could even check by plugging your x back in to check your answer, or maybe I ask you what the sides of the triangle are and you do 11 plus 7, 11 plus 8, and you plug them back in. But all they asked is whether or not there was a solution. So we do have a yes. All right, another example. Application 2. 2 coffee clubs are competing for business. Coffee Club 1 charges $15 for a reusable mug and $10 per refill. Club 2 charges $13 for a reusable mug and $1 per refill. Write an equation to solve for the number of refills R for which the 2 clubs charge the same amount. So we want Club 1 to equal Club 2. Okay. So Club 1 is $15 for the mug plus $1 per refill. R is the number of refills. Club 2 charges $13 for a mug plus $1 per refill. So you might already be able to tell this is going to end up being a special solution, because if I subtract one R on each side, they cancel on both sides and I get 15 equals 13. But actually 15 does not equal 13. So solve for R. R equals no solutions, because we got a false statement. How many solutions do you get? None. There are no solutions. So the 2 coffee clubs will never, ever charge the same amount. Coffee Club 1 is always going to be more expensive with that 15 for the mug. Sometimes your equations will have multi-step when you're having to solve them, so just keep in mind that. All right, so if we go about solving this, we have to first simplify on each side. Negative 3 times x, negative 3 times positive 1, 2 times x, 2 times negative 4. Distribute first, then combine like terms. So now we're taking our multi-step equations, and now we're going to throw in some that might have special solutions. So if I subtract 2x on each side, this cancels, and I get negative 3 equals negative 8, but it does not equal negative 8. So we're going to say x equals no solutions. So just some more steps involved in simplifying. And then our last example is very similar to something you might have to do on the state test. Complete the equation, okay? Complete the equation below so it has requested number of solutions. So you're going to have to make up a right side of the equation so that it will have the number of solutions that they asked for. I highly recommend you simplify the left side before you start, and I was nice and made these 3 all the same. So if we have 13x plus 2x minus 12, when we distribute that, that means it's 15x minus 12. Well, if I wanted to have no solutions, I want to make sure that x's cancel out. So I'm going to make the right side also have a 15x. And then I have to make sure the numbers that are remaining are different. So instead of negative 12, I'll put something else, plus 2. Okay. So you can write anything down except for this is going to have to be 15 because the coefficients must be the same. And here you can write any number but minus 12. You can't use that. All right. So there are basically no limit to the number of ways you can complete the right side of that equation. You can go simple or fancy. Not only can you do 15x plus 2, you could make up something that, like, when you distribute and combine like terms, you get something like that. So, there's lots of possibilities on how ornate you can get. This one is also 15x minus 12. So we wanted to have infinitely many solutions, which means the right and left side have to end up being identical. And I was saying a minute ago, you can go simple or you can go fancy. I could do something like 3 times 5x minus 4, because when I distribute that, I'll get 15x minus 12. Okay. Or I can do something where I have to combine like terms, like 10x minus 12 plus 5x. That'll end up being 15x minus 12. So there's no limit to the number of ways you can write it. Now, if you wanted to have one solution, you just have to make sure the x's don't cancel out, which means on the right, you cannot write 15x. So this number can't be 15. It could be negative 15, but it can't be positive 15. And then plus any number you want, including 0. You could just write 14x or 14x plus 0. But this can literally be any number. All right, so I'm just making some extra notes there. You don't need to make those extra notes, but those notes are just for you to read and understand how you can respond to that question. All right, so this is the end of our lesson on solving equations with special solutions. The next lesson, join us for that. We're going to be going over how to recognize the number of solutions and respond to that without actually solving the equation out. So we're going to call it solutions by inspection.